It seems like AI and robots are everywhere these days. It's really kind of crazy, doing these amazing things. But have you ever wondered who's coming up with all this? The people behind it all.
Yeah, it's easy to just focus on the cool stuff we see, but the people part is really interesting.
For sure. That's what we're doing today, taking a deep dive into Sergey Levine's work.
Oh, cool.
A real AI VIP, according to AIVIPs.org.
Okay.
They call him, get this, a trailblazer.
Yeah.
Not just doing research, but actually bringing AI into the real world.
His work is, honestly, it's all over. It's hard to say how big of an impact he's had, really. What I find most interesting is how he sees robots, not just as tools, but like a testing ground for AI.
That's interesting. So let's go back a bit. Our sources say Levine studied with Andrew N. at Stanford. Now, N is, well, he's a big deal in AI, right?
Totally, yeah. Like a pioneer in machine learning and all that. So for Levine, that's got to be a pretty awesome start. And you can see N's influence for sure. Like Levine's early work was all about AI learning from data, especially in situations that are, kind of unpredictable.
So not just following instructions, but figuring things out, more on their own.
Exactly. It's a huge change from how we used to think about robots. Everything was code, code, code. Levine's pushing for robots that can, learn and adapt, more like how we do.
Now, this is where it gets really wild. Okay, so there's this thing called reinforcement learning, RL. It's imagine you're teaching a dog a trick. You give them treats when they do it right. They try stuff, get rewarded. Eventually they learn. RL is like that, but with robots.
Yeah.
And the tricks are, well, way more complicated.
Yeah, good analogy. And Levine is one of the leaders in this. One of his big papers is actually called End-to-End Training of Deep Visuomotor Policies. What's so cool is robots could learn complex stuff just from seeing, like we would, They didn't need every single step programmed.
Wow, that changes everything. But it gets even, cooler. Levine doesn't want robots that just do one thing well. It's all about generalization robots that can take what they learn and apply it somewhere new.
This is where deep learning comes in, specifically convolutional neural networks, or CNNs, and of course RL. It's these networks, they're inspired by our brains, right? Help robots see patterns in data so they can learn from just a few examples and then, bam, use that knowledge for new stuff they've never seen before.
Okay, so, a robot learns to sort fruit. Can it then use that to, pack a box with different things?
Exactly. And this is huge. Think about factories, robots that can do all sorts of tasks. Healthcare, robots adapting to different patients. The possibilities are, endless.
That's pretty amazing. But it makes you think, what about when real-time learning is just too risky or expensive? Like in surgery, you can't have a robot experimenting on a patient.
Right. You're hitting on a key point. This is where Levine's work on offline RL comes in. It's all about learning from data we already have, like a huge library of experiences, not needing to constantly experiment. And yeah, you're right. It's huge in healthcare, where safety matters so much.
So a robot could learn from tons of surgeries without actually doing surgery itself. That's comforting. But how do you make sure it learns the right stuff when it's not getting, that real-time feedback?
That's the hard part, right? And that's where Levine's work is so important. He's made offline RL way more reliable. In his paper, Stabilizing Off-Policy Q-Learning via Bootstrap and Error Reduction, he basically found ways to cut down on errors. So even without that live feedback, the robot's actually learning the right things.
That's incredible. And it ties into what you said before, robots as a testing ground for AI. Can you talk more about that?
Sure. We always think about, AI for robots, but Levine flips it. Robots are the way to make AI itself smarter. They're in the real world, right? It's messy, unpredictable. AI needs to be way more advanced to handle that.
So it's like the ultimate test. Can AI really deal with the real world with all its, messiness?
Exactly. And Levine is proving it in amazing ways. Think about something like picking up objects. Easy for us, right? But for a robot, grasping all kinds of shapes, sizes, textures in a cluttered space, that's super complex. Levine uses these challenges to really push what AI can do.
Like he's saying, let's not just talk about smart robots, let's use them to build smarter AI. And that leads to another cool thing, imitation learning. Robots learning by watching us, like apprentices learning from a master. Sounds simple, but I bet it's hard to do.
Oh, it is. You can't just have a robot copy movements. It needs to understand why we do things, the nuances.
Yeah.
And adapt. Levine's got this thing called guided policy search. It's like a bridge between human demos and robots learning on their own. The robot watches, gets the key stuff, then uses RL to get even better.
Wow, that's mind-blowing. So we could have robots working with us everywhere, learning from us even when we do things differently each time.
Exactly. Huge for industries where people and robots work together, manufacturing, healthcare, even creative stuff.
But robots, even the super smart ones, still need to move around safely. That's where Levine's motion planning work comes in, like giving robots an internal GPS to move smart in changing places.
It's more than just following a line, though. He uses deep RL and trajectory optimization. So robots make decisions as they go, adapt to obstacles, even to us moving around. Really important in places like, warehouses or busy streets.
Can you give an example?
Sure. Imagine a robot in a warehouse, right? It's packed with stuff. Instead of a fixed route, it can use Levine's stuff to adjust on the fly, weaving through stuff, finding the best way. He uses this thing called latent space representation, which is kind of like compressing a huge file. It lets the robot process all that info about its surroundings way faster.
So not just reacting, but like anticipating and planning, like giving robots a sixth sense for navigation.
Exactly. And it's all part of Levine's big idea, robots that combine perception, control, and decision-making. It's not separate things. It all works together, just like in us.
It's like the difference between a machine following orders and a person using their senses, thoughts, and actions all at once.
Exactly. Levine's work on visual motor policies shows this really well. These policies link what a robot sees directly to what it does. It can react to its environment live, just like we do.
So it's not just robots that see and move, but robots that truly understand what's around them, make choices, and act on them. That's huge.
Absolutely. Think about, robots in warehouses picking and packing stuff super efficiently. Or in healthcare, doing delicate tasks. This integration is what makes those higher levels of robot intelligence possible.
And all this amazing work is happening with some of the biggest names in AI, right?
Yeah.
You mentioned Levine worked with OpenAI and Google Brain. Those are, pretty important places.
Totally. And Levine's done some important work there. He's really into making algorithms more scalable so they can handle tons of data and making them better at generalizing so they can do lots of different tasks. It's not just about cool demos. It's about AI that can actually make a difference in the world.
Sounds like he's always pushing the limits, but also thinking about how it can be used. That connection between, the research world and the real world is what makes his work so interesting.
That's what sets him apart. He doesn't just want to write papers. He wants to see his research actually solving problems.
So where can we see that impact? How is Levine's work being used today?
Well, his research on robotic grasping is being used in warehouses all over to make things more efficient. And his work on autonomous driving is being used by companies like Tesla, for self-driving cars. And those are just a couple examples.
It's wild to think his research isn't just changing, the academic world. It's changing the technology we use every day.
For sure. And as we wrap up this first part, I keep thinking about this question from AIVIPS.org. If Levine represents this generation of AI leaders, who's next? And how will they shape the future alongside robots?
That's a really good question. We've only just started talking about Levine's work, but it's clear he's a driving force in all this exciting stuff happening with AI and robots. I can't wait to dive deeper in our next session.
It's crazy how far things have come, so fast. And what's cool about Levine is he's not just building robots to, do specific jobs. He's looking at the big questions in AI, how do these systems actually learn and adapt?
Yeah, we've touched on that. One thing that comes to mind is, all the data these systems need. Think about it. For a robot to learn to grab something new, it might need to see, millions of examples. It's like teaching a kid the name of every single thing just with flashcards. It would take forever.
It's a ton of work, yeah. And Levine's got some really smart ideas. One I find fascinating is using simulations. Instead of robots having to learn in the real world, where they could break stuff, they can learn in a virtual world.
Yeah.
Way faster, way more efficient.
So it's like robot boot camp. They can practice without, messing things up.
Exactly. Try stuff out, make mistakes, learn from them, all in a safe space. And the cool thing about simulations is you can make a ton of data pretty easily. You can create all these different situations, test out different things. It really speeds up the learning.
But simulations, they're not the real world, right? There's always going to be a difference.
True. And that's where domain adaptation comes in. That's a big part of Levine's work. It's basically taking what a robot learned in the simulation and making sure it works in the real world.
So he's giving those boot camp robots a crash course in how to handle the real world.
Exactly. And Levine's done some important stuff here. He uses things like adversarial learning. You basically have two AI systems kind of fighting each other, which makes them both better. And domain randomization, where you make the simulation super varied so the robot can handle changes in the real world.
It's crazy to think. These robots could be training in virtual worlds right now, getting ready to come out into our world. It's exciting, but kind of scary too, right?
Definitely. But there's another part of Levine's work that I find really, really interesting. It's his focus on emergent behavior.
Emergent behavior. Okay, that sounds cool. But I gotta be honest, I'm not sure I get it. What does that even mean?
So it's the idea that you can get complex behavior from simple rules. Like, think about a flock of birds, right? Each bird is just following basic rules like stay close to your buddies, don't run into things. But together, they make these amazing patterns. It's not programmed. It just emerges from how they interact with each other and the environment.
Okay, I kind of see. So Levine's making robot flocks.
Not exactly flocks. But the idea is similar. He thinks we don't need to program every tiny thing a robot does. We can build systems where robots learn to interact, with each other, with the world. And from that, you get these complex, sometimes surprising behaviors.
So it's less about instructions, more about creating systems that can, adapt and change on their own. Wouldn't that be kind of hard to control? What if the robots start doing stuff we don't want?
You're asking the right questions. And those are exactly the challenges people like Levine are working on. It's not about, letting robots go wild. It's about finding ways to guide their development without, limiting their ability to learn and be creative.
It's like a balance between freedom and control, right? So how is Levine actually doing this with robots? Can you give me an example?
Yeah, sure. His work on multi-agent reinforcement learning is a good one. Imagine a bunch of robots working together to build something complex. Each robot has its own skills, its own goals, but they have to coordinate to get the job done. You can't program that ahead of time. They have to learn to cooperate, communicate, adapt to each other, all on the fly.
That sounds insanely hard. How do you even start to, design something like that?
It is tough, but Levine and his team are making progress. They're looking at different algorithms, borrowing ideas from game theory and economics,
right,
trying to build systems where robots can learn to work together, compete, and do things that, one robot alone just couldn't do.
So it's not just robots working next to each other, it's robots working together like a team. That opens up so many possibilities.
Yeah. And as Levine says, it's not just about being faster or more productive. It's about building systems that are more resilient, more adaptable, more intelligent because they can learn from each other, learn from the world.
This is all starting to feel really futuristic, Exciting, but also a little mind-blowing. Robots learning in simulations, adapting to the real world, now showing emergent behavior.
Levine is really changing what we thought robots could do.
He is. And it makes you think, what's next? As robots get more adaptable, more collaborative, more intelligent, what new things will they be able to do?
Yeah.
How will this change our lives, our work, how we even think about intelligence?
It's a lot to think about. And it makes me even more curious to see what else Levine has been working on. Okay, so we've covered a lot. Robots learning in these virtual worlds, working in teams, even showing emergent behavior. But there's this one thing I keep thinking about, something that feels, very human. Creativity. Can robots actually be creative?
That's a question that's been around forever,
Yeah.
and it's one that Levine is really trying to answer. He thinks creativity isn't, some magical thing only people have. It's more like a process, right? Exploring, innovating, refining, coming up with new solutions, testing them, learning from what happens. So it's like a systematic way to think outside the box.
Exactly. And Levine's using this idea in robotics. He's developing algorithms that let robots experiment, improvise. They even come up with solutions that honestly surprise the people who built them.
Hold on. Are you saying robots could be writing music or designing buildings or even writing poetry? That sounds like, I don't know, sci-fi.
It might be closer than you think. Levine's work on what are called generative models, it's really interesting. These are AI systems that can actually create new stuff. They learn from tons of data, music, art, literature, whatever, and then they use that to make their own unique creations.
So it's not about programming specific rules for creativity. It's about giving robots the tools to learn and explore and I guess express themselves. That's a whole other level of intelligence. But doesn't that, I don't know, raise some questions? If robots get more creative, more independent, what does that mean for us, for human creativity?
Those are important questions, and Levine gets that. He's big on responsible AI, transparency, accountability, humans being in control. He thinks AI should help us be more creative, not replace us.
So it's not about humans versus robots. It's about working together, combining our strengths.
Exactly. Imagine architects using AI to design buildings that are better for the environment, or musicians using AI to create music that's, completely different from anything we've heard before. It's about pushing the boundaries of what's possible creatively.
That's a way more optimistic view of the future. And it kind of brings us back to what we talked about earlier, robots as partners, not just tools.
Right. Levine sees robots as like collaborators, companions, even inspiration. He thinks AI can free us from all the boring stuff so we can focus on things that are, more creative, more fulfilling.
It's like this back and forth, right? Humans and robots helping each other to build a better future. And Sergey Levine is definitely a big part of that.
For sure. When you look at everything we've talked about, his research, his focus on ethics, it's obvious he's a real visionary. AIVIPS.org, pick the right guy. He's doing amazing work, showing what's possible with AI.
Yeah, it's been really cool to explore Levine's world and all he's done for AI and robotics. Reinforcement learning, emergent behavior, domain adaptation, robots being creative. It's all, pretty mind-blowing.
And it makes you realize we're just getting started. Who knows what's coming next as AI keeps evolving.
It's a future full of possibilities.
Yeah.
And I, for one, can't wait to see what happens. Thanks for joining me on this deep dive.